Hi, everyone, and welcome to Global Azure Norway, Day 3. My name is Harald Fjelbakken, and I'm a part of the Norwegian.NET user group who is organizing this event. And I will be your host for this session, and I am very pleased to welcome our first speaker for the day, Martin Hinselwood. Martin, the stage is all yours.
Thank you very much. Thank you very much, Harold. I have 50 minutes to talk with you about this idea, and I tend to change the name, Enterprise Evolution, that shows that you can too. I want to be very clear that there's no such thing as an agile transformation, a DevOps transformation, or any type of transformation. It's not like a caterpillar turning into a butterfly and then everything's awesome. It's a continuous evolution of your organization and your company towards some end goal and vision, and that end goal and vision keeps continuously changing. And I want to talk about a particular organization that has been through that evolution and has been for the last, I guess, 10 years now. 10 years, 9 years full time, 10 years since they started. So the idea, we're gonna mention a little bit about what is this DevOps thing that we keep talking about. I myself am a Microsoft MVP. I have been a Microsoft MVP for the last 13 years. When I started out, it wasn't DevOps, but these days it's a DevOps MVP. It was application lifecycle management back in the day. But DevOps has lots of different ideas from different people about what it is and what does it mean. And it can mean very different things to different people. So let me just run a little video for you. I'll go on mute so we don't get it.
Holland comes in for a pit stop. Time to refuel and change tires. Lou Moore himself changes the tires. Only 4 crew members, including the driver, are allowed to work on the car. It's a tense time. Holland stays in his seat, anxious to get away. Let's watch. The tires are changed at last. A crewman polishes the windshield as Holland moves away just 67 seconds after he stops.
So that was 67 seconds for a pit stop. If you were watching carefully, which I hope you were, you might have noticed a number of things. You might have noticed that refueling the car did not take the longest. They were finished refueling well before they'd changed the tires. And I don't know if you noticed, but changing those wheels looked like a very painful and laborious experience. They were out with the sledgehammer trying to get those tires off. They had very low level, low maturity engineering practices, you could say. And they were using it's technology of the 1950s in order to fulfill that ideal of that getting that fast pit stop. So 67 seconds was a fast pit stop in the 1950s. I'm going to show you a second part of that video, which is the 2013 Melbourne Grand Prix and the pit stop there in Formula One. So let me hit play again. I'll go on mute.
Hi, Martin, you're on mute.
Thank you very much for that. I muted for the video. I will start that part again. Where was I? Yes, there's a big difference between these two events. There's a lot more people involved, and I think that equates very well to the modern software delivery world. There's a lot more people involved in modern software delivery. We've no longer got a few graybeards sitting in a basement with a mainframe. We've got a lot of people involved in the process. It's a lot more complicated, and we need a lot more organization around solving the problem. So you can see that this team operated in a bounded environment. They all had a job to do. They all had a single job to do. So there's quite a lot of them there, but they're able to take care of that job very quickly. It's almost like it's automation. It's not really like it's people. They've automated away all of the problems. Yeah. Another difference you'll see that I don't know if anybody noticed, but do you see this gentleman at the back here? There are two, well, gentlemen. I don't even know whether it is gentleman, but this person at the back here, he's got a jack, and there's a person here with another jack that's lifting up the back of the car so they can change the wheels. At some point, this jack here must have failed, right? So they've got somebody there with a backup just in case, right? That's planning ahead, making sure that we are professionals and we do our due diligence. We have our backups in place to get that working. I think that's the purpose of DevOps. If I was to quantify DevOps as one single thing, it is this idea that we need to be able to both develop a way of doing something, deliver it into production, and operate it in production. I like Donovan Brown's for Microsoft's version of DevOps. DevOps is the union of people, processes, and products to enable continuous delivery of value to your end users. But it is a very wide thing, and depending on who you speak to, there's also this other thing, which is agility, which has a kind of similar purpose. You could say agility is the union of people, processes, perhaps not usually products, but people and processes to enable continuous delivery of value to our end users. And I think of it as two sides of the same coin. We have DevOps, and many people who are very focused on DevOps believe that agility is one aspect of DevOps. And then we have a lot of folks on the other side of the coin who are very focused on agility and believe that DevOps is just one aspect of agility. I would like to assert that maybe they're the same thing. They're just being approached from different directions. DevOps is an engineering practice to help improve that flow of value, and Agile is a planning and management process, practice, ideas, mindset shift. They both are really a mindset shift rather than individual practices, and getting there can be quite difficult for organizations. And in fact, organizations that focus on DevOps, and I'm going to use the terms DevOps and Agile synonymously. I believe they're really the same thing from the grand scheme of things from an organizational level. But well, whatever watchword you prefer, fill in the blank with. But teams that focus on DevOps, this is from the Dora Report, are better performing, better at doing their work. They spend more time delivering value, delivering new things. They spend less time on maintenance and support. Yeah, that's ultimately what we want to get to, and that's ultimately what DevOps is really designed to create in our world. But can you think of any massive failures of our ability to deliver? I'm thinking of particular products. I can think of two. I'm talking about Microsoft later, so I'm going to use two of Microsoft's biggest failures, and I'm going to use some rough data around that. But the first one oh, that went the wrong way. Let's go this way. Was a poor quality delivery. Somebody think of a really, what stands out in your mind of Microsoft deliveries when I say poor quality? I think you'll probably have the same idea of me, which is Windows Vista. Windows Vista was very poor quality. They had huge number of problems delivering that product to production. And it stemmed from systemic quality issues. I remember all of the videos that I saw at the start of videos and presentations that I saw at the start of the Windows Vista release cycle, talking about all the cool things they were going to ship, and none of them made it into Windows Vista because they just struggled to ship it. They took a massive brand hit for the Windows Vista release. Even once released, it had a lot of problems, and it cost them an awful lot of money. I've seen estimates that say it cost Microsoft up to $8 billion in lost revenue, lost brand, lost customer satisfaction. Yeah, that's really bad. I'm actually gonna beat up the Windows team again and say, can you think of another product that was a mismatch to customer desires? That the customers expected one thing, the product shipped, and the customers were not happy with the product that was released. It did not deliver the value that the business expected it to deliver. And I'm going to beat up on Windows 8, even though I was a huge... Unfortunately, the vast majority of users did not. They didn't like the new interface. They didn't like the new interaction capabilities. And Windows team ended up having to roll it back a year later with Windows 8.1. They rolled back a lot of the changes. And this was a massive, massive brand hit for Microsoft. The estimates that I've seen is that they lost nearly $12 billion in people moving to Mac, people moving to Linux, people not wanting to use Windows anymore because they felt like Microsoft wasn't listening to them. Microsoft spent a lot of money creating this new interaction paradigm in Windows 8 that suited both tablet and desktop, and it didn't work, but they spent 6 years building it, right? That's a lot of money, right? So this story that I'm going to tell you is from the first team, the first large-scale team inside of Microsoft that moved from a boxed software product, right, into a service, and why they did that. And their boxed software product was being released on a 2-yearly cadence with a service pack halfway, and they moved to continuous delivery as a service. And ultimately, why you should think about this too. What can you learn from the things that happened to this team that you can take back to your organization, right? So I'm not saying do everything. Absolutely, I am not saying do everything that they did. But we can learn from what happened to other people, the mistakes they made, the things they tried, get ideas for the way we might want to change the way we work. So I'm going to talk about the Team Foundation Server team, the Visual Studio team at Microsoft. Team Foundation Server was a very good product in its time. It was very popular. I know it definitely had some issues, especially as it started getting a little bit older. So it first shipped way back in 2006. The early betas were available. 2008 was really the big launch. That was about the time I became an MVP in 2008. So I've been working with this product for a very long time. One of the problems that they ended up with is that the release cycle was so long that they struggled to deliver what the customers needed. Yeah, you potentially there's a bunch of developers watching this. You all struggled using this tool because it didn't provide the capabilities that you needed when you needed it. The technology of how we delivered software, right? How we wanted to deliver software and the tools we were using to build software moved quicker than the product that we were using to support our endeavors in that. Yeah, Team Foundation Server started to lag behind in the world. And this is really the story about how did they turn that around? How did they go from lagging in the industry to leading in the industry? And yes, we can the elephant in the room there is GitHub as well, but we're going to talk about this is all before the GitHub acquisition. So I really like this fellow. I have a lot of respect for Satya Nadella. If you read his book, it's awesome, and I think there's a really important quote in here. There cannot be a more important thing for an engineer or a product team than to work on the systems that drive their productivity, right? I would rather any day of the week trade off features for productivity. I'm going to show you some data around why for this team, this is the Azure DevOps team at Microsoft, that it had massive payoffs. And this quote from Satya Nadella is after that, and he applied it to the entire organization. If you have a productivity issue on your team, you should be focused on that. You should not be focused on new features. If you are more productive, you'll build more new features for your customers than if you just deliver features based on your existing productivity. So it is really, really important. It's almost the most important thing to spend time on your own productivity. Okay. And I think hopefully, why is that going backwards? Right. Microsoft are in a very different place now. This data is actually from 2008, so it's 3 years old. Way back in 2012, when they started their transition towards agility, they were doing very few deployments per day. You could probably count on your hands the number of deployments you can do, maybe your hands and your toes, the number of deployments they were doing per day. But as of 2018, and this is just data from Azure DevOps, so that's them using Azure DevOps to deploy their own tools, 183,000 deployments per day, right? That's more than the number of software engineers that they have. So their products are doing a lot of deployments. 2 million Git commits per month, right? Think about how often the change in TAC that happened when you moved from server-based source control to distributed source control systems like Git. If you haven't already, this is something that happens is you commit more often, more frequently. It's easier to find where the faults are that you introduced. Right, that's one of the things of getting faster. 6.3 million builds per month. I mean, these numbers are just huge. And part of that, the things that they did to get there, this is the things that this team has learned so far. I'm going to cover as many of these as I can in the next 32 minutes. If I skip over anything or I don't go too detailed on anything, please feel free to hit me up on LinkedIn, and I can provide more detail. I have presentations that are a whole hour long just on each of these topics. So there's a lot of information there, and I'm going to just give you the highlights so you can maybe see where you want to dive into. So really the first one is focus on the customer. Right? You have to focus on the customer. Really nothing else matters. If you focus on the customer, everything else should come back from that. But listen to your customers. And don't just listen to your customers based on what they say, right? That's one part of the story. Also listen to your customers based on what they do in your product, which means you're going to need some form of telemetry in order to really listen. But this team listen through a number of channels. They have the ability to just report a problem or suggest a feature. That was on user voice. I think it might still be on user voice just now, but you can do that yourself. They have people monitoring Stack Overflow and teams that own the features, right, that people are talking about on Stack Overflow, go monitor it themselves as well and answer questions in there. So there are real developers who work on the product answering those questions to make sure that not only are they correct, but if there's a problem that they need to go fix, that they know about it as soon as possible. They also monitor social media as well. And you can make a suggestion directly in the product. That's something you can do as well, right? It doesn't matter how big a product you're building or how small a product you're building, getting that feedback built into the product, make it easy to get feedback and make it easy for your developers to see what was going on at the time the feedback was given, right? So if you're reporting a problem, make sure you collect the logs or what the current state, maybe screenshots, whatever the person that's reporting it allows you to take. But that's really, really important. And make sure if you're using feature flags, if you're using the ability to turn features on and off, like doing little private previews, make sure you collect data. Are people turning off it? Are turning off those features after you turn them on? Why are they turning them off? That's gold data for your team to figure out how do we need to change this feature to make it more viable, more stable, more capable. These are all things. So listening to your customers is really important, and I find a lot of teams really don't do that. And I've got a little bit of data here. I think it might be a little bit small for you. I don't know if I can't quickly and easily make that bigger. There is a zoom function. Maybe I can do that and do it like there. There we go. I can make that a little bit bigger. So this is the customer satisfaction, right, and data about a customer based on the customer. So each of these is a customer in Azure DevOps. These are the number of engaged users for that customer. The fourth one down from the top is a customer I'm very familiar with. I've worked with them a lot. There are many other customers in here, and you can see they've got a number of engaged users. I'm not sure what MOM is, but they've got how much they're using boards, repos. Sorry, not how much they're using, the satisfaction index of the users in those spaces. So only 62% of users are satisfied with boards for the top item, 52% for repos, and I'm not sure what the next one is. Azure, I'm not sure what the last one is there. But they're looking at this data. The teams that own those features are looking at this data. Their product owners are looking at it, seeing how much, which customers are happy with it, which customers aren't, and then going and talking to those customers and finding out why they're not. So, for example, one of the customers that I work with, who's on this list, had very low satisfaction at one point in Azure boards, and part of that was because of the customizations that the customer had built into Azure boards and imposed on their users. So it wasn't exactly Microsoft's fault, but Microsoft allowed those customizations to be made that inhibited the ability of people to use the product. Therefore, it still looked like it was Microsoft's fault. You need to take care of that as well. If you add too many customizations to your product that allows users to customize it in ways, or admins, right, to customize it in ways that give a negative outcome for the people using it, you will still take a hit for it. You will still have less usage, and that customer may switch to another vendor because of the low satisfaction of people on the team. So it's really important. There's really not a better thing than listening to your customers, but also doing something about it. This is the definition of done for that team at Microsoft. It didn't start here, right? But their definition of done at the moment is live and in production, collecting telemetry, supporting or diminishing the starting hypothesis, right? That means that every feature you build, every feature you add to the product is an assumption, right? You've got there's assumptions baked into that. You assume that users will use it. You assume that they'll get benefit from it. You don't know, right? The only way to know is to have an idea about what behavior we're trying to change in those users, figure out how we monitor that change in behavior, right? And then monitor it. So we deploy the feature and we see if we change the numbers, right? That's hypothesis-driven decision-making. If there's no data, we're shooting in the dark. We've got no idea whether our features were successful. I worked with a bank in the US. There's the average from the Standish Group in Boston. They do a chaos report every year, and the last report that I saw, the average percentage of features that your customers use that you build is about 35%. 35% of the features that you build are used. If you think about it, for every $1 million that you spend on a product, $350,000 is of value. The rest is not of value, right? So we want that number to be bigger. That would be awesome, right? But this bank believed they believed that they understood their customers way better, that more of their features were used than anybody else, that they must be on the high end of that because they really understood their customers and were building just the right thing. We added application insights to their product. We monitored it for a few months because they have month-end users and that kind of thing. We didn't get to year-end users, but we had month-end users and some year-end users because everybody's year is different. And the data showed that about 10% of the features were being used. So for every $1 million they invested in their product, only $100,000 of value they got out of it. That's horrendous, right? But they didn't know that. In fact, they believed something different. How do you change that? You need data. You can't change anybody's mind with an assumption. So collect as much data as you can, but make sure you collect the right data as well, right? If you collect the wrong data, you can change behaviors in your employees. Do not, for example, collect. In fact, I'm going to show you in a minute what not to collect. That's a good one. Awesome. I'm glad I have that in there. At the moment, Visual Studio, for example, pushes about 7.5 terabytes of telemetry into their data analytics system through application insights. So that's a lot of data to sift through, but it's all data on how fast does Visual Studio load, what features are being used, how often they're used, in what context are they used, and they can go spelunk that data using some of these tools and look at the different sets of data. So KPIs, for example, are important, but you have to be monitoring the right thing. So here are let me move my mouse over here. Here are the teams on the left here. So there's the Agile team, which is the boards, Azure boards, and they have 1, 2, 3, 4, 5 teams working on that area of the system. And then you can see the live site incidents repair work items older than 2 sprints, right? So they don't want bugs found, live site repair items that get stale. That means we're not fixing the underlying problem. We're just, we're rebooting the server. Okay, now it works. Wait till the next failure. We don't want that. We want to fix the problem. So this is that. And you can see some teams are not doing so well, so other teams are doing better. And it could be that those are just hard problems to solve. Maybe there's major architectural changes in there in order to knock these things off. So that's something we need to do. So there's some data to monitor. And in fact, they monitor usage of the product. So how do the customers use the product? So here you can see acquisition, engagement, satisfaction, churn, and feature usage, right? We want to monitor that in our product. We also definitely want to monitor velocity, but maybe not the velocity that you're thinking of. Time to build the product, time to self-test, time to deploy, and time to learn, right? How quickly are we able to turn around some of those feedback loops for the engineering teams, right? How quickly can they deliver new features? And then if you're building a service, software as a service, which is a very good way to get users more actively engaged because they're always on the latest version of the product, we can monitor things around live site health, right? Or whatever your product does, you want to monitor what does success look like for your product, right? Some of these items might make sense. Some of them might not in your world, okay? So this is just for this team. You need to come up with your own measures. I really recommend the white paper and the guide from scrum.org on evidence-based management, right? Getting the right data, monitoring the right data to drive the right behaviors in your teams and in your product, and stop using data that drives negative behaviors. On that topic, would you like to see some data that we know for sure drives negative behaviors? I've seen it time and time again. This is not my list. This is the Azure DevOps team's list. However, I 100% agree with all of these. Things they do not monitor: original estimate and completed hours, lines of code, we all know that one, team capacity, team burn down, team velocity, and number of bugs found. None of monitoring those metrics will not result in positive outcomes for your teams or for your product, okay? You will get a bunch of vanity metrics out of that that provide no benefit, okay? If you want me to dive into any individual one of these and why they provide no benefit, hit me up on LinkedIn and I will happily do that. I have a couple of blog posts around velocity and story points about why that sucks beyond the team. And you can also ask some questions in the Q&A as well. Please add them in there and we can try and answer them at the end. Cool. So once we've really figured out what the customer wants, like really got obsessed, bunny boiler level over our customers, we want to find the most painful thing and do it more. What do you remember from the video at the start? What was the most painful team for the Indianapolis painful thing for the Indianapolis team? It was changing the tires, wasn't it? Yeah. It took them a long time to change the tires. That was the whole time, was figuring that out. They refueled the car in the time it took to change all of the tires. Whereas in the Melbourne Grand Prix, it took them seconds to change the tires. Very few seconds. They fixed that problem. And actually, if you look at the history of Formula One, the thing in the 90s that was the biggest problem, because they got the tire changing down, the thing that became the constraint, right, for getting faster pit stops was refueling. So they first tried to have bigger refueling hoses. Yeah. So if you make the hose bigger, you can fire more fuel in at once. But there was a number of very famous accidents in the pit stop where everything caught fire and race car fuel went everywhere. And that's because they became too big, too difficult to lock on. We had other faults, right? So they tried something, it didn't work. Okay. And what did they move to? Did anybody notice how long it took to refuel the car in that pit stop in Melbourne? I will tell you, it took 0 seconds because they did not refuel the car. What they worked on in the last all the 10 years between the 90s and that one in 2013, what they worked on was making the car engines more efficient. Let's not have to refuel. Let's refuel less rather than trying to pump fuel faster into the car, which is more dangerous, right? So you got to iterate around the problem. You got to figure out what it is and get better at it. What is your most painful thing you have at the moment between the idea that your customer or your product owner or whoever's coming up with the ideas has and delivering it to your customer? What's the most painful part of that story? Right? Focus on that. Do it more. Get better at it. Automate it. Do those things. That's where your focus should be. What's the most painful thing that inhibits your productivity? For the Azure DevOps team, they had a really painful time around this 2-year release cycle. Code, test, stabilize, code, test, stabilize. They found that by the time they got to the beta, and you and I got copies of the product to validate, and we went, oh, but it doesn't have this feature, and it doesn't have this other feature I really want. It was too late to get it into the RTM because they've already planned that work. They know what they have to do. That means it has to go into the next release cycle, which means we are not getting it for 2.5 years. That's what it means. We're not getting it for 2.5 years. If you have a 2-year release cycle with a beta halfway, when your customers give you feedback on the beta, 2.5 years, the whole release cycle next, because you might be able to get it into the next release cycle. And quite often they found that they couldn't even get it into that one because they'd already started planning the next version of the product, and they were all booked out, which meant it was potentially 6.5 years to get that feature. And that became too long. That might have been okay many moons ago, but it's no longer good. So they moved immediately in 2012. They moved to a sprint-based model. They started doing Scrum, right? And they started doing 3-week sprints, which is pretty aggressive for a product of that size, right? 650 people working on it. But they thought, well, we really need a little bit of a safety net. So we're going to have a 2-sprint stabilization period between the 5th sprint and the 6th sprint, right? That's the plan. That's what we're going to do. And what they wanted was a nice ebb and flow of technical debt and bugs and stuff we hadn't done. Yeah, you know, all those things that we might not be able to do right away because we're pushing quite aggressively. Let's have that nice ebb and flow where we deal with it towards the end of the sprint. We then build it up during the sprint. We deal with it. We'll do all that. That was the plan. But that's not what happened. What happened was all of the developers working on the product went, well, we've got this stabilization safety net, right? I can fix it there. Right? We need to get this done just now. Let's leave that bit till that stabilization period. And what happened was technical debt and bugs and stuff not done just started skyrocketing into that stabilization period, and the 2-sprint stabilization period was not long enough. Right? I've seen this happen before, even before I heard about it from this team. This is what happens when you have that safety net. So they switched it up. Their take 3, what they're doing, and pretty much what they're doing now, and they've been doing for the past 8, 9 years, is 3-week sprints. They've been doing 3-week sprints with a 1-week deployment. It actually takes longer now. So this is not quite identical to what they do now, but 3-week sprints. They just moved to 3-week sprints. The output from every single sprint since they started was deployed to production. Every single sprint. Like, end of the sprint, that's what's deploying. I think that is fantastic. And what they found was in moving to that model, they had to focus on some of those things. They had to get better at delivering what their customers wanted, right? They also, so that was that focus on customer. They also get better at the delivering each of the features, because at the end of every 3 weeks, they have to deploy that functionality. So it has to work, it has to be done. So we're going to do less new stuff, but do more of the things that have to happen to get into production. And by doing that, they had to pay down their technical debt, the things that they struggled with, the past undone work from all that waterfall work. And they ended up at the end of the first year, in 2012, they were delivering 22 features to production each year, right? At the end of 2013, with no new people, apart from the usual ebb and flow of people arriving, people leaving, 58 features. They nearly tripled the number of features by focusing on productivity, right? And going slower, doing more due diligence, higher quality work. They were able to deliver 3 times as many features to production as they did in the first year. Right? That is the power of this process of focusing on doing things right, not doing things fast, right? And you can see maybe they had a massive architectural stuff that they had to go fix to get between 2013 and 2014. So they didn't get a massive increase, but they still increased. But then they doubled it again for 2015, doubled it again for 2016, and the 2017 data there is not quite the end of the year. They were on track to deliver a little bit more again. That 300 features, 260 odd features, how many years doing 22 features to production would it take to get that 262 features? And more of those 262 features were valuable to customers. More of them. A higher percentage is being used. They're getting rid of old stuff in the product. Very, very powerful story. Maintaining this can be particularly difficult. You'll be familiar with some of there's a saying that your branching pattern will follow your organizational model. If you have a coding department and a testing department, you'll end up with a dev branch and a test branch. The world doesn't work that way, but that's how we built stuff. And then if the testers have two teams, you'd have the testers team 1 branch and the testers team 2 branch, or the coders team 1 branch, and you would end up with lots of active branches. Git helps move to a much more lighter weight model. Even the Windows team at Microsoft is on Git. They have a massive Git repo, but they are on Git. And what this team developed was something called release flow. GitHub Flow and Git Flow. GitHub Flow is really complicated. Right? I almost never, I don't think I've ever recommended Git Flow to anybody, okay, any customer. GitHub Flow is a very simple model where you have your master or main branch, and you create topic branches off that, make a small change, pull request that topic branch in, right? That's everything's a topic branch, whether it's a new feature, a fix, a bug fix, whatever, doesn't matter. Just these little short-lived branches. The release flow includes the release branch at the bottom there, because what they found was it took them up to 3 weeks to deploy their product, right? And if they want to fix something in production, they need to be able to fix the existing version of the product. Let me kill that and turn it off. There we go, it's done. They need to create that branch. So M129 was the output from Sprint 129, and it only existed for the length of time of Sprint 130, and then they created the M130 branch that only existed for the Sprint M131 time. Okay, and they're still using pretty close to that model for parts of the product. Other teams have moved to completely continuous delivery, so they don't need the release branches, so they're just doing GitHub Flow, and that's much more powerful. You want to minimize the number of branches you've got, but not to the level of incompetence. Yeah, you still got to protect your product and protect the real world. And in order to do that, you need better engineering chops. Feature flags are really important. So build out those feature flags and be able to turn on features. But be very careful, okay? One of the things that Microsoft failed a lot on early on was turning on features the day of a really big conference, right? So here's some data. Let me see, there's the data of what happened when they turned a bunch of features on. I think this was one of the Azure, one of the big Azure events where they announced a bunch of features, turned them on, and they had massive performance issues before launch. And one of the things that they changed in the way they deliver software was that you must have the features turned on 48 hours. You're only allowed to show at a conference features that are turned on 48 hours before the conference. That way you've got time to kick the tires in production with everybody else using it. So if you log into Azure or you log into Azure DevOps 48 hours before a big announcement from Microsoft, you will see the features that they're going to announce. You might not know where to find them, but they will be there. Okay. So I am going to speed up a little bit because we're getting close to time, and I've got a couple of things that I definitely want to cover. There's other things I'm quite happy to skip over. Again, we can always do another session. I'm sure there'll be another Global Azure Norway, and we can always do more and more and more. I'm very happy with that. One is monitoring your live site incidents, right? Don't treat them as production issues, right? Like somebody else's problem. Somebody else monitors production. It's your problem. You are the team building the features. You are the team that caused this problem. You are the team that should be dealing with it. And if you are in an organization that has the dysfunctional behavior that another team manages production, and your engineers that build your product, your development teams don't have access to production, you need to figure out how to fix that. You build it, You deploy it, you own it, you run it, you support it, is the only way to build awesome software that I'm aware of. Okay, it's very hard when it's somebody else's problem to support it, for you to do all of the things that you need to do things well. And if you're building services at really large scale, you want to be as transparent as you can with your customers. You want to be letting them know exactly what the problem was, why it was a problem, what you're going to do to fix it, what's the type of time frame for that. These are blog posts from Brian Harry, who's the product unit manager for TFS, Azure DevOps at the time. And he published blog posts with all of the telemetry, as much of the telemetry data as he could, showing exactly what the problem was, what they're going to do to fix it, why there was a problem in the first place, full root cause analysis, and publish everything. That creates a level of trust with your customers. I, as a customer, feel like you trust me to tell me what went wrong, and I feel confident in the things that you're telling me that you're going to go do to fix it, right? And then even if it happens again, because outages are going to happen, you have that confidence that that those issues are going to be dealt with. There's no such thing as 100% uptime. There's no such thing as no bugs, right? It's how you deal with those problems and how professionally you deal with those problems that will build that level of trust. I would also point out that if you're got any sort of partial automation going on, you are so hosed in your ability to deploy quickly. Here is code, PowerShell code that was stored in OneNote and emails and then run by team members when they were doing deployments. If anybody doesn't realize yet what would happen if you ran this option, it would bomb out because it's got curly quotes and not straight quotes. And that can be very difficult to debug in a big script that you're copying and pasting around. Never a good idea. So automate everything. Everything should be automated. There should be no human intervention between your product being committed to source control, right, and it getting into production, except for approvals. Approve the pull request, right? Approve the deployment. Everything else should be automated. There shouldn't be the possibility of making a mistake in that process. Okay, so automate everything as much as you can, right? And even if you do all of that, all of those things, you won't be able to be perfect every time. So when you do have problems, you want to be able to control that blast radius. You want to be able to control how many people are affected. The way Azure DevOps do this is through a ring-based model. So they have rings 1 to 5, and here you can see ring 1 is internal users, so they have an instance. It's all one instance of Azure DevOps, but it has and it interacts with itself. But the ring 1 is all the internal users. Ring 2 is the smallest external data center, which I believe at the time that this was written was in South America. I think it was Brazil. So smallest external data center, and then do your largest external data center, right? So you minimize the blast radius, and then eventually you're going to end up with all the rest. And in fact, I know that the Windows team is in ring 5, so they are the last ones to get any features that come down the line, because they are the most risk averse. And Microsoft does look at their customer profile and the problems they've had and the risk to those customers. When it's really big customers, they have an engagement manager and move them to the rings that make sense for the level of viability. Yeah, so create that live site culture inside your organization, monitoring and focusing on everybody is responsible and accountable for delivering high quality, valuable software to production. The last thing I want to mention, which I have a few seconds left on my clock here, but I'm going to mention it anyway, is we have a little bit of a paradox, right? In software, you'll know this. That's my timer going off. Is the innovation. So getting things out there fast and reliability with control, which is why having development teams and operations as separate teams doesn't work, because they are at each other's throats trying to get things out or not get things out, as the case may be. So when you're scaling, I want you to think about autonomy. Think about the level of autonomy that your developers need. Everybody should read Dan Pink's book, Drive. It's about the truth about what motivates us: autonomy, mastery, and purpose. Autonomy is we want to feel like, as people, that we're in control of our own destiny, right? That we choose what to work on. We want to be good at our job. That's mastery. And we want to feel like the work that we do contributes to something more important, right? If we don't have those things as humans, our job kind of sucks and we don't care. We don't care about the work. We disengage from the process and we're just not interested. And that does not build good products. So really focus on that and figure out where your level of autonomy and alignment should be. And also control your team structure. Don't have, hopefully, you're all well aware that you shouldn't have a development department and a testing department. That way lies pain and disaster. So make a single engineering department. And indeed, I really suggest creating cross-functional teams, feature teams that include both people deciding on what the features are, people building the features, and people monitoring the production hardware. Make sure you have that cross-functional team that interacts directly with your customers to get feedback and build and support and maintain those features. Let me see. I have a few seconds left. I'll see a list of questions. I don't see any questions yet, so I will keep going until there are questions. Okay. I have a few other things I can talk about in the next 7 minutes. I would rather take questions from you and answer those. But I have probably like 5 minutes of other stuff that I'd like to cover in here. But yes, please ask your questions, and then I'm sure the organizers will interrupt me with those features. Let's see. Well, let's talk about some of the things they've learned in that. If you're familiar with something called shift left is really about improving quality. And this idea that somebody else is responsible and accountable for security or operational support, or I don't know, anything that needs to be true that you don't have the skills for on your team, anything that needs to be true to ship your product to production. Like it has to be in legal compliance. It has to be under SOX compliance. It has to be under, I don't know, some health regulation. Whatever those things are, everybody on the team needs to understand what those things are and how their work is impacted by that. One of the things that this team did was they wanted to move very heavily away from big manual testing. They had a lot of end-to-end automated tests that are difficult to support and maintain. So they needed a version of the application running in order to run these L3 tests. And they wanted to move to less L3 tests. And over the course of a number of years, which that's what's going on here, every sprint there, they're reducing the number of end-to-end tests. You can see they started with about 27,000 and they ended up with 0. I don't know how many sprints in between that is. Is that 20, 30 sprints it took them to pay back that level of technical debt? But at the beginning of this process, it was taking 48 hours to run a build and test of the product with massive amounts of computing power put on the back end of that to make that happen. Lots of parallelization of the build, lots of parallelization of tests, which sometimes created the circumstance where a test could pass and then fail. because you're running 2 tests at once on the same hardware or equivalent. So by the end of this process, a developer could build locally in 3.5 minutes. 30,000 unit tests running locally in 3.5 minutes. So that allowed people to have a lot tighter feedback loop for the engineers on quality, a lot tighter feedback loop on regression, and a lot tighter feedback loop on knowing when you've broken something, so you can fix it right there and then when you know that it's a problem. So I think that is a really, really important story, and that use of pull requests and bringing it in. And I would kind of like to end on that it's a journey. That's why I called it an evolution and not a transformation. Your evolution is there's no end to evolution. You're constantly going to be changing to suit the changing demand of the business, the changing demand of your customers, the changing needs of your business and the customers, and you've got to be able to change yourself to keep up with it, and make sure you stay on track. So you're going to be constantly changing. So learn to feel comfortable with change, to experiment, to try new things that might not be successful, and realize that there are no failures. There are only learnings. So the only failure is in not learning from your failures. Okay. I think that's really important. Thank you very much. Are there any questions that have come in?
Yeah, I'm gonna jump in here and take one of them.
Awesome.
So one question is, how are traditional hosters changing their operations team, or how should they change their practice? Because they are traditionally a little bit difficult, or that change is difficult because they have maybe not so much competence in working agile. They don't have infrastructure as code competency, or lagging behind. Any reflections around that?
Yeah, they're good. They're going to have to learn, and the whole. One of the reasons I use the evolution analogy is think of an ecosystem of animals, right? If one animal is no longer suited for that ecosystem because their food source disappears, what happens to that animal? If another animal comes along that is a little bit more aggressive or more suited to that niche than the animal is currently in, what happens to that animal? Same is true for companies, and it's why banks are running scared of the new fintechs that are coming along and taking all their business, right? Adapt or die is the mantra there. And to be honest, for most, I don't have, for most hosters, there's not a lot of loyalty from customers because they've traditionally had a bad experience with hosters. I know I did with many of the hosters that I've worked with. I now have a host. I use a WP Engine, right? And I have had an awesome experience with them. They have solved every problem I have had. They've preempted many problems that I have had and fixed them before I knew about them, and then told me that they'd fixed it afterwards. Those are the types of things that you should be doing to build trust and loyalty in your customers. And I happily pay them a lot of money to support my website because they provide that level of service. Whereas, I could pay $20 a month to one-on-one and have a really bad experience, or I can pay $1,000 to WP Engine, and I'm much happier paying the $1,000 and getting something that actually works. When you as an individual feel like you get value, you as the customer feel like you get value, the prices matters less. Does that make sense? Yep. So focus on happy customers. Honestly, if you get happy customers, nobody cares.
Perfect. I think that's what we have time for today. So huge thanks to you, Martin. Great session. And if people have more questions, I'm sure they will type them in and follow up with you or add you on LinkedIn and so on.
Absolutely. I'm on LinkedIn. I'm on Twitter, but I'm more on LinkedIn. And I just want to leave you all with this awesome picture of the Microsoft cat riding a rainbow unicorn. DevOps and Agility are not any magic that's going to solve your problems, but they will make your problems transparent. Okay, you still have to deal with them.
Yep.
Thank you very much.
Thank you, Martin. Thanks. Have a good day.
Right.
And for the rest of you guys, we will start our new session very shortly. So let us just let in the new speaker, and we are going to be right with you. Hi, everyone. Hi. Welcome to Global Azure Day 3. I'm Harald Finnbakken. I'm a part of the Norwegian.net user group who is organizing this event. If you were listening in before, this is the second session of today, and I'm very pleased to welcome our speaker, Petter. Petter,
Hello.
you take it away.
Yeah, thanks for having me. My talk today is about the Windows Virtual Desktop, and I'm going to go through some use cases and some reference designs to go along with those use cases. Just to kick it off, a little bit about me. I'm a senior consultant at Lillevik IT. I've been in the IT industry since 2003, so I barely missed the Y2K issues. I've always been an all-rounder, but the last few years my focus has shifted to Microsoft 365 and Azure. So that's me. Just quickly, a little bit about what is Windows Virtual Desktop, and in essence, it's RDS as a service, or Remote Desktop Services as a service. It gives you the main infrastructure components in an RDS environment delivered and maintained by Microsoft as a service for free. I say free because you have to pay licenses and, well, Azure consumptions for some of the components in Windows Virtual Desktop. So just to visualize what you have to be maintaining and what Microsoft has will be maintaining. If you see that all the stuff on the right side is managed by Microsoft, and they provide all this scaled and highly available for you. And the only thing you have to consider is all the stuff on the left side, which is well, basically the session hosts. If you're familiar with RDS components, the session hosts and everything revolving them, so imaging, profile, policies, and all that stuff, while Microsoft will be handling the broker service, gateway, load balancing, all that stuff you really don't want to be managing yourself. And Windows Virtual Desktop is also the only way currently to get Windows 10 multi-session, which is quite awesome because traditionally we would be using RDS environments when we have server operating systems, but now we can have a client-side operating system, which is a little more handy, a little more user-friendly. I guess some would say they are more bloated, but then again, more user-friendly. So that's kind of a great thing, I think. So in order to have Windows Virtual Desktop, you will need some bare minimum stuff like Azure AD or Microsoft 365 tenant with Azure AD in it. And you need, of course, an Azure subscription and some licenses. If you are using Windows Virtual Desktop with Windows 7 or Windows 10, you would be only needing the Microsoft 365 Business Premium or higher licenses. That would be the E3, the E5, A3, A5, and the F3. Some would argue that maybe F3 is not higher than Business Premium, but anyway. You can also license this using the Windows E3, E5, A3, and A5 licenses. And you might notice that these are all Microsoft 365 licenses. You can't buy a single license like you would on an on-prem environment. And if you're running Windows Server operating systems for your session host, you would also need to have RDS CALs with software assurance for your operating system of choice. Additionally, you would also need a traditional Active Directory that is synced with Azure AD. And that can be either traditional domain controls using AD Connect, or you could also be using Azure AD domain services if you don't already have a traditional Active Directory. So with that out of the way, let's skip to some use cases. And the first one is also the most basic one. It's I just want a desktop in the cloud, and I have nothing from before. So why would you want this? Well, it's great for convenience. You could connect to your desktop from anywhere in the world and with any device. And if you're, for example, if you're out traveling and your device or your laptop or breaks, gets stolen or anything, you can just continue working on your phone or your tablet, or maybe pick up another cheap laptop, and you would have your desktop already in the cloud, and nothing really has changed with that one. And it's also great if you're working with multiple environments. For example, if you're a consultant doing most of your work with clients in their environments, but you also have your employer's environment, then you can have Windows Virtual Desktop, for example, with your employer, and then use your local device with all your clients. And of course, it's also a great case for testing, demoing, and doing proof of concepts. And the way we would do this is you set up your users in a Microsoft 365 tenant, including licenses. We deploy Azure AD domain services, and then we deploy Windows Virtual Desktop. There's also a few little steps in between there, like you also need a Azure subscription, like I mentioned before. And also when you deploy your Azure AD domain services, you would also deploy a virtual network. But these are the main steps in this use case. And as you can see, there's really not a whole lot. And the design for something like this is quite simple. You have your Azure AD on the left side, and you have a sync down to Azure AD domain services, and you have your session hosts that are authenticating towards Azure AD DS. And on the right side, you see all our endpoints, our clients, which could be Windows clients, Mac clients, iOS, basically anything that can run HTML5 browsers as well. And they connect through the internet to the Windows Virtual Desktop control plane, which Microsoft provides control planes in all over the world, basically. And the control plane has all the main infrastructure components like web access, gateway, the remote desktop broker service, and all that. So your endpoints and your clients would connect to the control plane that is physically closest to them, so to provide the lowest latency, and then the control plane connects to the session host and acts as the gateway there. And as you can see, the session hosts are not directly connected or exposed to the internet. So that's also a great thing about this kind of setup, is that none of your services are really internet exposed. And kind of the same use case or scenario, but in this case, we already have AD Connect. So we have some services from before. And when we have AD Connect set up from before, it would be much the same, but we will be skipping the Azure AD domain services because we already have a traditional AD that is synced to Azure AD. And in this case, we would need a connection between the session hosts in Azure and the domain controllers. This can be VPN, or you can also use express routes. And optionally, in this case, you would have a domain controller in Azure, really just to lower the latency in logons for your session hosts. But you would still need your VPN or express route, the connection between the domain controller on-prem with AD Connect and your domain controller in Azure. And as you can see, the setup is still not really advanced. It's quite simple. We have the VPN between our on-prem environments and our Azure environment. And you have the domain controller on-premise doing user sync up with Azure AD, and the session hosts are doing authentication towards that domain controller over the VPN connection in this case. You could expand on this design, as I said, with an optional domain controller in Azure, and you could also consider having some sort of central storage of the user profiles in Azure if you are using multiple session hosts. So the next use case is if you want to lift and shift your entire on-prem to Azure. Your entire on-prem will then perhaps include some RDS services already. And a couple of reasons why you would want to do this. If you have older unreliable hardware or just hardware that is out of support, so if something breaks, it can't be replaced easily. Or if your company is relocating from one office to another and the new office don't include any place for on-prem servers, or simply if you want easier disaster recovery than you can achieve with your on-prem environment. So in this case, you would start by establishing a connection between your on-prem environment and with Azure, and then setting up Windows Virtual Desktop with some fresh new session hosts, and then test all those session hosts to make sure that they are working with your on-prem environment, because in this case, all the servers would be on-prem and your applications running in Azure on the session host, and they need to be working. Then use something like Azure Migrate to lift your servers up to Azure, and after making sure that the Windows Virtual Desktop works after migration, you just tear down whatever old RDS environment you would have. So this is the kind of setup that I would do from starting here before we are lifting our on-prem. It's kind of the same that we had in our last use case. I've added the Azure files for central storage of user profiles. And in this case, we are not setting up a domain controller in Azure from on beforehand, since we will be lifting the domain controller with all the rest of the on-prem stuff into Azure. And as I said, this is where you are before the lift and shift, and hopefully after you have done your lifts, your setup will look something like this. Quite the same, just all your servers running in Azure. But what if you want to do a lift and shift, but you have to take it slowly? And this is maybe if you have larger environments that are not suited to have a lift and shift within a few hours or a weekend or something like that, then you can use Windows Virtual Desktop as kind of a setting it as a primary tool for your users. And if you do that from the start, then they will probably not notice that much of you moving servers in the back end. So as we see here, establish Windows Virtual Desktop as you did in the previous case. Instruct your users to use Windows Virtual Desktop as their primary tool. And it's really important that you set the expectations right in this case, because since Windows Virtual Desktop is living in Azure and your servers are all on-prem, then Windows Virtual Desktop will be slower at first because of the added latency between Azure and your on-prem environment. But once this is all set up, you can migrate servers and applications at your own pace without really having to bother your users that much. So this is basically the same as the start of our previous lift and shifts use case. You have your VPN set up between the Azure environment and your on-prem, and all the session hosts are doing authentication and application access over that VPN connection. But somewhere in the middle, when we're starting moving servers, it can look something like this. In this, we see that we have moved some servers. We have established a domain controller in Azure to reduce the logon times. And we still have some servers left on-prem. But in the end, the hope is that you will end up with something like this, where all your on-prem is gone and moved to Azure. And that way you can decommission all the stuff you have on-prem. So that's the lift and shift use case. But what if you just want to work efficiently from cheap hardware and preferably have the same user experience from any device out there? And you can use Windows Virtual Desktop as a fully fledged workstation using existing mobile devices, something cheap like the Raspberry Pi, old and redundant unused hardware that you have laying around. If you're going with the Raspberry Pi way, you might want to take efficiently out of the equation, because you would be forced to work in the browser only, and that might not be efficiently, but still every mobile device you have or old hardware would be nice to be used for working efficiently from rather cheap hardware. And a couple of things to consider in using this in this use case is that you would want to have a short path, and you want to have personal session hosts. And this is because the keyword here is efficiently, and you don't have to have short path, you don't have to have personal session hosts, you can use pooled. But if you want to be working efficiently, then you need short path to have that reduced latency between your end device and your session host. And you also want to have personal session hosts so that someone other than you on your session host isn't hogging all the resources, because that is one of the things that might happen when you're using pooled session hosts. You have 10 users on one server, and maybe 1 or 2 users are using 90% of the resources, and the rest of the users on that session host will then have a bad time and not really be working efficiently. And this is an example of how you might be setting up such a use case. It's a bit more advanced than the last design, and that's mainly because we are using short path, preferably. And as you can see, we have some endpoints on the left side, and they are using a VPN connection to Azure. so that they have a direct line of sight from the endpoint up all the way until the session hosts, because that is a requirement if you're using short path, is the direct line of sight. So in this case, you would have your endpoints that are on-prem. They would do the initial connection through the internet to the control plane, and then the connection to the session host would be using the VPN connection and using short path. The rest of the stuff is kind of the same that we have had in the other reference designs. We have a domain controller with AD Connect or Azure AD domain services that's providing sync up into to Azure AD and providing the traditional Active Directory so that session hosts can have their authentication. We also see that we have an instance of Azure files that we are using for central storage of all the user profiles. In this case, we also could have endpoints on the internet, as you can see on the right side. It would function pretty much the same, but since there's no direct line of sight between the endpoints and session hosts, you can't use short path, so you will see some increase in round trip time, latency, and bandwidth, really. I've seen cases where with using short path, the round trip time and latency has been cut in half, and bandwidth has been increased by tenfold. So short path is really great for gaining that extra performance or reducing all that latency between your endpoints and your session hosts. So what if you want to offload workloads from your local machine so that you can free up some resources on it? This is also a great use case for Windows Virtual Desktop because you can run heavy applications or workloads in Windows Virtual Desktop instead of running them locally, and thus increasing your productivity because you're freeing up time waiting for renders or exports or something like that. And one example is if you're doing, for example, video editing, you can do all the editing part of the work on your local device. And then when it's time to render the finished video, you can do that in Azure and then still continue working on your local device instead of twiddling your thumbs waiting for the render to be complete. And a couple of things that you need to consider in this use case. Here you would preferably publish apps and not desktops, just to have that more fluent workflow for your end users. And that in publishing apps, they can kind of look like they are locally installed, even though they are running in Azure. So it's really user-friendly for the end user in this case. And again, preferably use personal session hosts instead of pooled session hosts, and also have short path enabled or use it whenever you can. And also for this, please remember to use fslogics for your central profile storage. That way your only benefit isn't just that you have central storage, but with fslogics you will also decrease the logon times because it's a much faster technology. The design for this is actually the exact same as before, because in the previous example we were using desktops, but in this case we are using published apps, and the design doesn't really change much. It's just a matter of publishing the apps instead of the desktops. So let's move on to our next use case. That is, if you just want a management environment for your Azure infrastructure as a service that you already have, of course. And traditionally, you would set up a single Windows server for management with a public IP that doesn't have modern authentication, so you can't have MFA, and one that scales kind of poorly. Now, you could swap out Windows Server for Linux Server, of course, but you would still have a public IP and no modern authentication, and it's the same for scalability, really. And here is where, if you use Windows Virtual Desktop as your management environment, it's a lot more scalable. Your session hosts aren't exposed to the internet, and the logon to Windows Virtual Desktop is based on modern authentication, which means that you can use all of Microsoft 365's security features, like MFA, conditional access, identity protection, and so on. Plus, this kind of environment can live side by side with any Windows Virtual Desktop that you have for your users. And so instead of having your single server for management that you have to either size up or scale up, you have Windows Virtual Desktop that would not only scale up, but you can also scale out with more session hosts if you want. And you can also kind of silo it in on the same way that you would with a single Windows server management. And in this example, we have one user Windows Virtual Desktop for your main users, and then you have your management Windows Virtual Desktop for your IT department, for example. And you also have your main Azure Infrastructure as a Service down on the right side here. And here you can see that the management Windows Virtual Desktop and the user Windows Virtual Desktop is completely separate. There's no traffic running between them. You could if you want, but there's really no need for it. But they are both using the same domain controller with AD Connect or Azure AD DS. They're using the same for authentication. And that's really the only thing that they are sharing. The session hosts in management Windows Virtual Desktop only have access to the management of all the servers in your Azure Infrastructure as a Service. And the user Windows Virtual Desktop part only have application access to your Azure Infrastructure as a Service. And as you can see, they are sharing the same control plane, but you can split them up in different workspaces, for example. And besides, it doesn't really matter that they are sharing the same control plane because that's not managed by you, so you don't have to really worry about it. And yeah, as I stated, this can live side by side fine, and your IT guys can have both their management via Windows Virtual Desktop and the user Windows Virtual Desktop in the same client as well, so they don't have to do any changes on their local device if they are switching over to the user Windows Virtual Desktop. But what if you just want a traditional remote desktop environment and you are starting from scratch? This is kind of the ideal situation for a tech guy like me. You have nothing. You're starting from scratch. If you're building Azure infrastructure from scratch, I would recommend using the hub and spoke topology. And in this case, you would consider your Windows Virtual Desktop as traditional RDS, but siloed in and living on its own little spoke. The reason why I would prefer the hub and spoke topology in this case is that it makes it a whole lot easier to lifecycle manage your environment, and it also increases security and the visibility of all network traffic and services and so on. And the design in this case is a bit more advanced, but it's like I said, this is the fun stuff for a techie like me. You have your hub, which is where you will have all the main services in your Azure environment. And all services that are shared between spokes, for example, in this case, you have a domain controller with AD Connect or your Azure AD DS, that is shared between all the spokes. So we can put that in the hub in this case, and the session host in the Windows Virtual Desktop spoke can communicate with it. And all the servers in spoke 1 and spoke 2 also can communicate with it, but they don't necessarily can communicate between one another. So in this case, you would have spoke 1 and spoke 2 will be living in their own little world and not having any communication between them, but you can if you want. And in this case, you would then, even when you spoke 1, the services there are out of their lifetime, you can just tear them down without having to consider all the other stuff around. For example, if I'm going to take down spoke 1, I would not have to consider the Windows Virtual Desktop environment, because they are living in its own little spoke and its own little world. So this is a great way to lifecycle, as I said, your lifecycle manage your environment, and could also save a little bit of money on common resources like the Azure Firewall in this case, and VPN connections, for example. In this design, all of our spokes can use the same Azure Firewall, and they can also be sharing the VPN connection to our on-prem environment, either by having some sort of connection between the VNets or by using VNet peering, which is perhaps the most simple way of doing it. So that's the most advanced design, I think, but it's also the most scalable one and sensible one, if you ask me. And then lastly, we have the I just want a locked down environment. And this can be a lot of reasons. For example, if you have some highly secured applications that need a tighter set of security rules, you could use your group policy objects to lock down your session hosts even further with session time limits, clipboard redirection, printer redirection, camera, microphone. All that can be disabled using either group policy objects or the settings in Windows Virtual Desktop. And you could also make use of a quite new feature that is in preview, which is called the screen capture protection, which enables you to block out any screen capture applications on your end user device, for example, print screen or any recording software on the endpoint. And this makes a great case if you are having applications in your Windows Virtual Desktop that you don't want your users to have on their local device, for example, because of security issues or concerns. But at the same time, you can provide access to that application from anywhere in the world and on any device if you want to. And the design is pretty much the same as some of the simpler designs that we had earlier on. You could go without the short path, so you could skip the VPN connection, but as long as you can have it, I think you should have it. So unless you really want to cut some costs, you should have your VPN connection so that you can utilize the short path feature. And like I said, the screen capture protection should be enabled. That's a setting that you do in Windows Virtual Desktop, not a infrastructure thing. So enable it, and it'll block and detect and block screenshots, screen share, and others. For example, if you're users are using Teams and sharing their screen, it would just simply black it out. So, some final thoughts from my side. Windows Virtual Desktop has a lot of use cases. I have covered some of them, but far from all of them. And they have a lot of use cases, but it also has a lot of configuration options. And some of the use cases can be configured in multiple ways. So, and some of the use cases can also be configured in the same way. So there's a lot of different use cases, a lot of different configuration options. It really depends on what you want to have from Windows Virtual Desktop. And it's not always ideal, but in most cases it'll do the job. There are use cases where perhaps Windows Virtual Desktop isn't the best, but it will still do the job. And for a lot of companies, it's basically free, since if you have your Microsoft 365 from beforehand, and maybe you even have your Microsoft 365 business premium licenses already in place, then all you would have to be paying for is the compute consumption for your session host, or maybe some Azure AD EDS or central profile storage with Azure files. And there are a lot of features currently in preview that will improve the service immensely, or are already doing so. And from its first GA, when it became general available, it has gone through a lot of change. There's a lot of new features that has come to Windows Virtual Desktop. So if you only had a look at Windows Virtual Desktop when it was first released, I would highly recommend you checking it out again. So because there's so much features there that are new, and has improved the service quite a lot. And lastly, use reserved instance and other cost savings methods. They are a lot more flexible than you might think. And perhaps do set up your production environment, take a look at how it works and how your performance is, and scale it rightly, and then go along and do reserved instance, for example. And with that, we are a little ahead of time, but we are actually at our questions part. So, Harald, is there any questions for us?
Yeah, perfect. Thank you. Let me go through a couple of the questions here. First one off is there anything you should consider regarding to the VM sizes? Any preferred sizes, and what would you think around sizing of the VMs?
Well, first and foremost, if you're setting up a demo environment or a proof of concept environment, I would probably use the B series because of the pricing. But in a production environment, I would not be using the B series because they kind of feel a little bit sluggish, if you know what I mean. And also, if you're packing your users quite tightly on your session host, then consider actually going for the VM sizes that have GPUs in them, because that will offload your CPU quite a lot. So yeah.
Great. But I think that brings us to maybe relevant to the next one, but do you have any experience around the latency round trip to the Norwegian Azure data centers and VVD? And could you potentially replace your development laptop by using VVD?
Yeah, we are actually using it at my current employer, and quite happy about it. And the latency is quite small. It doesn't bother you at all. I mean, it's still remote desktop services, but in practical use, it's really not noticeable at all. And if you could replace your development laptop, I think so. Yeah, just be sure that you're using not the B series, because we actually tried that with our devs, having Visual Studio running in Windows Social Desktop. And what we experienced with the B series is that tab completion, for example, it just didn't work. But as soon as we switched to a D series VM, then it was all fine and dandy.
Nice. So then you can potentially outsource your local hardware and mostly virtualize it.
Yeah.
Next question, just scrolling through them. Have you encountered any tricky scenarios with VVD, like publishing older legacy apps, or anything particularly tricky that you want to comment on?
Actually, I think the one I had the most problems with is the Edge, because that is it's a little bit different than using just publishing an exe file. But no, not really. The most tricky scenario, or what we struggle mostly with, is actually when you're publishing applications and the user click the application, it's waiting for it to start, but the logon time is a bit too long, so they get they click again, and hopefully they'll work this time, but it takes a little bit of time to log on the first time you kick off a published application. But I think that's the most trouble we've had so far.
Yeah, perfect. So last question that is in for now. If you're already using Citrix, could you use VVD or combine it? And what value would that give them?
Yes, you could combine them. Citrix is one of Microsoft's partners, and I think always have been in regards to Windows Virtual Desktop. It was a launch partner. So Citrix is value adding to Windows Virtual Desktop, if you could call it that. So we have your Windows Virtual Desktop in like the foundation, and you have Citrix building on top of that. And yeah, definitely you could combine them, and it would value add. I have to admit that I'm not that familiar with Citrix, so exactly what value it would give you, I am not sure. But yeah.
Perfect. I think that's it for the questions. Thank you so much for the session. It was super.
Yeah, thanks for having me.
Yeah, thank you. Then we will have a short break, and we'll start up again at 3 o'clock. So just stay tuned if you're listening in. And again, thank you. And I'll put on the break in between. Thanks, everyone. See you later.
Yes. Bye.
There. Hi everyone, and welcome to Global Azure Norway Day 3. My name is Oddbjørn Bakke, and I am part of the .NET user group here in Norway that are organizing this event. And I will be host for this third session for today. If you have any questions during the talk, please use the chat to post them, and I will include them after the talk. And here is our speaker for this session, Bran van den Klingenbach. So without further ado, the stream is yours.
Hi, yeah, thank you for the intro. Let me share. Does everybody see my screen? I hope it's shared properly. Everybody, welcome to Global Azure Norway. Thank you all for joining this session. Of course, a big thanks to Global Azure Norway for setting up this great event and for having me. Today, I would like to talk to you guys about application container security on Azure Kubernetes Service with Aqua Security. First, a little introduction. My name is Bram van den Klinkenberg. I'm 41 years old. I'm married. I have 4 kids, and I'm a cloud native engineer at Fullstack. I once started out as a help desk employee, and later on became a Windows Server administrator, but somewhere along the line, I wheeled into the process management side of IT. And about 4 years ago, I decided to get back into tech. Since then, I've gained a lot of experience and knowledge in Linux, Azure, Kubernetes, and Azure DevOps, and using Terraform as infrastructure as code, and lately also GitHub Actions, and of course Aqua Security, which I've been working with now for about 2 years. Before we go and dive into Aqua Security, I would like to tell you something about the major risks that the NIST, that's the National Institute of Standards and Technology, defined for all the core components of container technology. I think it's good to have a knowledge about those major risks, so you can link it to the features that Aqua provides. After that, we will go through Aqua Security as well, of course. We'll go through all the components of Aqua Security and explain what Aqua offers as countermeasures for the major risks that we will discuss. And as last, I will demo Aqua Security, where we'll see a Azure DevOps pipeline building a container. And before pushing it to the registry, it will scan with Aqua the image with the compliance policies that we have set. And we will also see Aqua at work at runtime. Missed those. And at the end, I will be happy to answer some questions, of course. So, like I said, before we dive into Aqua, it's a good thing to have the major risks clear that the NIST has defined. NIST, by the way, is a part of the US Department of Commerce and is responsible for developing security standards and guidelines. So those core components are images, registry, orchestrator, container, host, and host OS. For each of them, there are multiple risks defined, which are defined as major risks. When we look at images, they can have vulnerabilities like missing critical updates. They can have configuration defects. Could be that your container is configured to run as root, which is a risk. It can have embedded malware or embedded clear text secrets. But also the use of untrusted images is a big issue. There are a lot of images available on Docker Hub, so not all of them are safe, as we know. Then if we look at the registry, those risks that they define there are insecure connections. If you have an insecure connection to your container registry, it could be that you have a man-in-the-middle attack, where a hacker can either intercept the traffic and either fetch your administrator or developer credentials or the contents of the image, of course. Stale images are also big risks. We have out-of-date versions, missing updates and are still in your registry and are still able to be deployed. And of course, insufficient authentication and authorization restrictions is a big risk. So a good RBAC solution is needed. Then the next major risk component is orchestrator. Those risks over there are unbounded administrative access. If you have everybody handing out administrator access to the cluster, and you're running all sorts of sensitive level workloads, I don't think that's something that you want. Unauthorized access could be, for instance, with Azure Kubernetes Service, you can hook up your AKS cluster to Azure Active Directory. If you do not hook it up to AD or Azure AD, that can cause a weaker account management and orphaned accounts on it. So if somebody leaves the company and still able to access your cluster, also not something that you want. Also, poorly separated inter-container connectivity is a big risk. If you have an internet-facing application which runs on the same virtual network as an internal-facing treasury management application, it's a risk. Mixing of workloads, which is closely related, is also a big problem if you have, or a risk if you have internet-facing application running on the same node as a internal-facing application. And last, for the orchestrator risk, is the node trust. If you have a weak orchestrator configuration, that can cause untrusted nodes to be added to the cluster, but also the compromise of hosts or unencrypted communication between the orchestrator and the host. So those are the major risks regarding your orchestrator. Then container risks. Once you have your image, you want to run it, of course. So containers instance of your image. Vulnerability within the runtime. If an attacker is able to exploit vulnerabilities and compromise the runtime software, it can allow the attacker to access your other containers within your cluster. Unbounded network access from containers is a risk. If you have every container being able to connect to all other containers within the cluster, it's a big risk, especially if you have different sensitive workloads running within a cluster. Insecure container runtime configuration is also an issue. By default, there's a limited set of system calls, and if you widen those system calls, for example, that could expose the container and host OS to increase risks. And also, container runtime configuration could be that your container is allowed to mount sensitive directories on the host itself. And there's also application vulnerabilities, of course. Think of cross-site scripting or SQL injection. Those are vulnerabilities within the containerized web app that you built. And then the last component is the host OS. If you do not use a OS to run containers that's specifically meant for, if you use a host OS that does more than just running containers, that brings a larger attack surface and brings more risks with itself. Also, the fact that you share a kernel with all your containers is a risk. Your host OS itself can have vulnerabilities. The components of it can have vulnerabilities which could potentially impact all your containers running on your host. Improper user access rights is also something which is something of a big risk. If people are allowed to SH into every machine and just start managing containers on your host itself, that could potentially impact more than just the specific app that you try to manage. And then we have the host file system tampering. If a container is allowed to mount sensitive directories on the host OS, that container can then change files in their directories, of course. which could affect the security and stability of your host itself. So if we look at the all those major risks, then now we can have a look at what Aqua does, and later on we'll also discuss how Aqua mitigates most of those risks. So Aqua, as it says here, provides a full lifecycle security for your cloud native applications, and that is containers, cloud VMs, serverless functions. It provides preventive controls to secure the development pipeline. It protects your application in runtime and detects and blocks attacks. And it provides visibility and auditing for security, risk management, and compliance. That's a nice description of Aqua. So over here we see we have an overview of all the Aqua components. It's good to just know what all components we have to run Aqua. Number one is the Aqua server that provides the UI for Aqua, and also for integration with third-party components, and it coordinates all the security-related activities of all the other components. Aqua server itself runs as a container. Then we have the Aqua database. It's a Postgres database. It could run as a container, but it's advised when you run it in production is to use Azure Postgres database, for instance, to use a platform as service database. And in the database, all the audit logging is stored, but also all configuration for the Aqua server itself. Then the number 3, that's the Aqua gateway, that handles all the communication between the Aqua server and Aqua enforcers. We'll get to the enforcers a little bit later on, and also uses the Aqua database for the configurations. Then we have the Aqua Cyber Center. That's a knowledge base which is maintained and operated by Aqua Security itself. So it's a SaaS solution. It consolidates and maintains all the information on security vulnerabilities, malware, license requirements, and other data required to enforce the security controls that you want. And all the information in the database comes from the US National Vulnerability Database, software vendors, and all other threat intelligence sources. So it's a quite extensive database with a lot of sources in itself. It's a SaaS solution, as I mentioned, but it's also possible if you have an air-gapped environment to run it on-premise yourself. Then we have the Aqua scanners. The Aqua scanners can scan images during build time. They scan your images runtime, but also in your container registry, it can scan the images. And then we have several enforcers who will go through every one of them. First of all, the Aqua enforcer. This enforcer provides the runtime protection if you're running containers, and it does it based on the policies that you define within Aqua itself. It also provides runtime protection for your host OS itself, and also the enforcer runs as a container. Then we have the micro enforcer. It's a little bit like the Aqua enforcer, unless it cannot be run on a host itself, like with Azure Container Instance. Then you use the micro enforcer to deploy with your application in your Azure Container Instance, and provides the runtime protection in there. Then we have the Aqua VM enforcers. They enforce runtime protection for your hosts. Then we have the nano enforcers. and they can enforce functions runtime policies, like for example for your Azure functions on Azure. Only for Linux though, those nano enforcers. And last we have the Cube enforcer. It's does almost the same as the Aqua enforcer, except it does not give you host protection, and it's it can only run on Linux host OS, and also runs as a container. Then on the left side of the overview, we see several integrations. The first one is the monitoring system, so you can hook it up to Prometheus to get all sorts of metrics from Aqua itself. Then we have the CI/CD integrations. You can hook it up to Azure DevOps. The image registries you can hook it up, so you can connect with your Azure Container Registry for daily scheduled scans of your images. And then we have the SIEM system, so you can also hook it up to Sentinel. A couple other integrations that we do not see on the picture here are you can connect it to Log Analytics. So all your audit events can be sent to your Log Analytics workspace. And it can hook up to Azure AD for user authentication, which is an important one that I suggest to hook it up to. So I hope it's a lot of information. It's a big system, Aqua, but I hope you have a bit of an overview of what Aqua does and the major risks that we discussed. So now I would like to have a look at all the countermeasures that Aqua give you compared to the major risks that we discussed earlier. So we will go all through them, through all of them: the image, the registry, the orchestrator, container, and host OS countermeasures. So first of all, like I already discussed earlier, Aqua can scan your images during build time through the integration with Azure DevOps. It scans your images within your container registry, and it can scan your images on your host. And each of those images is scanned for vulnerabilities in the OS packages, but also in the development language files. So these countermeasures take care of the vulnerabilities, the configuration defects, the embedded malware, and the embedded clear text secrets. And the use of to mitigate the untrusted images within Aqua, you can configure it to only allow images to be run from a certain container registry. So you can say, hey, you're only allowed to run images from my Azure Container Registry. Then with regards to the registry itself, like I said before, you can configure Aqua to only run images from your Azure Container Registry. You can scan daily at a certain time for images. And you can also configure Aqua to scan for stale images defined on custom checks that you built yourself, and configure Aqua to block them from running as well. And you can also integrate automated scans into your CI process to ensure only authorized images can be used. The use of a secured connection with your container registry is not something that Aqua can enforce, and would be something that you need to configure yourself. So in our case, the Azure Container Registry has always a secure connection, so that's not an issue. And within Azure, you can of course configure role-based access to the container registry. Then if we look at the orchestrator countermeasures that Aqua provides, you can configure Aqua to enforce user exit policies to container resources, like viewing or editing. Aqua also monitors user access and blocks and alerts on authorized access attempts. Aqua also has a firewall, in which you can limit network connectivity between workloads. And Aqua performs host integrity checks, including vulnerability scans, checks for malware, to make sure that your host OS is also secure. Then with regards to the container countermeasures, there's a lot. It can detect and prevent port scanning. It can detect and prevent connections to IP addresses with poor reputation. Aqua can set real-time audit events on policy violations and send it, of course, to your Sentinel and have actions based on that. It can check for configuration drift. So if you're in your container and you try to install something or try to adjust configuration files, then Aqua can scan and block that as well. And the Aqua can block non-compliant images. If you scan your images during build time or within your container registry, it compares it to policies that you set. If it does not comply with these policies, those images will be marked as non-compliant, and then you can configure the runtime to not let any non-compliant images run. You can also configure Aqua to prevent certain volumes to be mounted in a container. It can block certain executables within containers, and Aqua can also manage and enforce SecComp, so secure computing profiles to unwanted syscalls, and Aqua can unlock all container events. And then the last part, the host OS. Aqua continuously scans your host OS with, for example, the Aqua Enforcer. It scans for vulnerabilities and malwares. It logs user login and logout events on the hosts, and also invocations of, for example, sudo. Also, Aqua scans hosts for configuration issues, and it can restrict, of course, containers from mounting specific volumes or writing to specific volumes of directories. And Aqua can restrict access to your host OS as well. So the fun part, the demo, of course. It's a lot of information. I hope you have a bit of a overview of what the major risks are and how Aqua can countermeasure most of those risks. And in this demo, I will show you how Aqua integrates with Azure DevOps for scanning your images during build time. And we can also show Aqua at work during runtime. Oh, sorry, that's the wrong one. So now let's go to the over here. So in this demo, let me show you the pipeline. I created it in the classical way, so it's a little bit more visual for everybody. Over here, you see a pipeline that builds a container image. It logs into the Aqua registry to retrieve the scanner image. Then it scans the build image that we just had here, and then it pushes it to the container registry. I will show you quickly also show Aqua itself. Over here we have the dashboard of Aqua. Within Aqua, you can set assurance policies. And you see here, at the moment, we do not have any controls enabled. So when I run this pipeline, we should see that it runs fine and it doesn't fail at all. But we will also see the Aqua Scanner report already. So while this runs, I will show you Aqua a little bit. So in here, the assurance policies, like I said, are for the scanning of your images. So every time it scans an image, it checks it against these policies that we set here. For instance, you can check for if a container runs a super user, if it has sensitive data, if it has malware. You can allow specific images or block it. Also allow or block certain packages within an image. And you can also check, say, hey, I don't want any vulnerabilities found be high or critical. Or if you say, hey, the score that Aqua gives it, I do not want it to be above 7, you can also use that as a policy. So for now, we are running the pipeline without any policies. Over here, you can see that it built the image, and here you see that the scanning is currently busy. See if I can create a little bit bigger screen. So we see here that it has been finished and it's pushing the image to the registry. But if we look at the build, there's a Aqua scan report. So that's really nice for developers. And when you look at it, you right away see the scanned image and how many vulnerabilities it has. So you can see it has 28 high and 68 medium. Then when we look at the vulnerabilities, you can exactly see for what packages or files it exactly is. And if there's a solution, it also says how to solve it as well. And within Aqua itself, every time there's a run, you can find it back here. So we see right here that this is the pipeline that just ran. So everything fine now, but of course we want to set some policies. So let's say, hey, we want to check for super user vulnerability scores. We do not want it to be above 7. We want to check for sensitivity data, check for malware, for example. And we save this. And we try to run the pipeline again. Of course, here we saw that the image is allowed because we didn't have any policy set at all. So it always is allowed the image and registered as compliant. If we run the pipeline again, of course, nothing has changed to the image. It's still the same image that we're building. Then we will still see that the build task will still succeed and the image will still be pushed to the container registry. But we will see that the image will be marked as non-compliant. The reason why it's still pushing to the container registry is because we did not have this option set yet. Fail the Aqua step within your CI/CD pipeline. So if we enable this one, when it checks the image against the policies and it fails those compliancy policies, then it will fail the build job, and the developer would be able to check the Aqua scan report of why the build pipeline has failed. It's almost done. Sorry for waiting, guys. Should just be a couple of seconds. Yeah. Okay, so it scanned the image again. And then when we check the Aqua scan report, it says, hey, image is non-compliant. And it shows here why, because it runs as root, and the severities, the image contains severities that are marked as high, and also the CVE score by Aqua exceeds the one that we set in the policies. Now, if we set this step over here, and we would run this pipeline again, then eventually we would see that the step will be marked as failed, and the image will not be pushed to the container registry, which would prevent you from being able to deploy the image later on if you do not have the option set to not deploy non-compliant images. So here you can see that when the how Azure DevOps connects to my Aqua instance is through a service connection that you provide within Azure DevOps itself. That way it knows how to connect to your Aqua instance and fetch those compliancy policies. As we see here, that the build has failed due to least of one of images not being disallowed by Aqua security. Again, if we look at the scan report, it doesn't change anything. It's still the same, marked as non-compliant. The only difference is now that it actually failed the build step, and it did not push the image to the container registry, preventing from having non-compliant images within your container registry itself. So this is how we scan images during build time. Now I would also like to show you some runtime features. Within the runtime policy, we can set it to, for this demo, I'm going to set it to audit at the moment. And later on, I will show you what it does when we set it to enforce. For now, if we would say, hey, my image is not allowed to run curl, for example. And we would need to drag my screen to show here. I'm going to make the screen a little bit bigger for you guys to read it. So if we would run a demo or just an Ubuntu image, we can see that we are able to run curl without any issues. But if we would then change the policy, change the enforcement mode to enforce, and we would save it, and we would go back to our container, and we want to run curl, we can see right away that permission is denied. So that's a really cool feature for the runtime. Within the runtime policy, you can also say, hey, the specify for which registries you only want to be allowed. For instance, if you do not want to allow images from Docker Hub to be run, let me just, this pod should go away now. Yeah. So if we save this here, so for now, we also said, hey, we only allow images from our own container registry or from Aqua or the host images. And we would, for example, try to run a different web app that's being pulled. Oh, hey, just 1 sec. This is nice. Of course, during demo time, it doesn't the demo gods are not helping over here, I see. Let me check the runtime configuration again. Yeah. Let me check. I think that the image, I think it has already been downloaded once before. So it's on the host right now, the image for the demo. I'm trying to try to run it before. So it's on the host, which is allowed at the moment. So I haven't run this one. So if we would like check, you can see here that the Nginx container is a crash back off. And if we would check the pod, then we can see screen a little bit better readable. Use of unauthorized registry. So here we can see that also this one is directly working on the runtime. So which is a really cool feature as well to prevent from unauthorized images to run on your environment as well. In this runtime policy of here, of course, I configured here your Azure container registry, which is allowed within Azure. Within Aqua, there's a option for integrations, and here we have your Azure container registry added. So here you manage the image registry connection. If you just want, most of the container registries are supported. Here you just provide the URL of your registry, the username and the password, and then it can configure to the container registry. And here you can schedule a task that will run every night, for example, to scan all the images that you have within your registry. So for example, here I scheduled one, and it will go through all the images within your container registry. Is there any other cool stuff that I can show right now? Yeah, like I said, the Aqua is pretty big, so it's a bit too big to show everything within this session. Like I explained, the main features are the assurance policies here, where you can set all the policies that you want to be applied when scanning images for compliancy. And the runtime policies speak for themselves, are all the policies that you can set to protect your runtime. If anybody has any or wants to see any stuff or has questions, then please let me know. Then for now, this is the end of the demo. Just to remind you here, you can claim your attendee learner badge if you want. Just scan the QR code. I will leave it on here. I hope you like the session, and if you have any questions, please let me know. Or if you want to see some more stuff, also happy to supply.
So yeah, that was a really interesting talk. I hadn't heard about this product, and it seems really, really nice.
Yeah, it's like I said, it's a big and extensive product, but it helps you with countermeasuring almost all major risks that NIST has defined. Yeah, and it can help you on every.
A lot of people do this manually, and yeah.
Yeah.
So we haven't got any questions yet, but other than we have this from NNUG. If you speak a lot on events and you like speaking on events.
Oh yeah, no. The reason I don't have much experience at speaking at events yet, but I like to take on challenges, and speaking in public is a challenge for me. I got ADHD and with ADHD and some accompanied other issues coming together with it, which doesn't make it easy to speak in public. But yeah, I would like to. I like to take on the challenge, and also take maybe this moment to. I think that speaking in public is not something in the second nature of most engineers. So if there are other engineers think, hey, crap, I feel the same way like he does. Like when you're thinking of speaking in public, and you think, hey, I'm getting all panicky and sweaty and scared to do it. Please contact me, because I like to exchange experiences, and maybe also people who have conquered that fear of speaking in public. Please reach out to me, and yeah, maybe we can help each other out. I think it's for me. Nobody, of course, enforces you to speak in public, but for me, I think it's as a person, it's something that helps me. But also as a professional, I think. So yeah, I don't speak a lot yet. That's why I spoke on Global Azure on Azure Live, sorry, a couple of days ago, and now this one. So if you do it more, it becomes less scary to do it, and I hope it also if maybe other engineers experience the same and they see me doing it, they think, hey, I can do that as well. So yeah.
It was really good. So great. Yeah. Keep it up.
Thanks. Yeah, so, thanks. Will do.
Don't see any more questions now. So we can wait a little bit and see. Yeah, this is my first Global Azure as a host. Yeah. So really felt it at the first hosting I had.
Yeah.
It was. And
it's also weird, of course, now not being in front of public, but being behind the screen. Maybe behind the screen it makes a little bit less. It makes it a little bit easier, but yeah, it's different.
Easier in front of people because there's a lot of things that have to go right.
Yeah.
And you have to check the gear, and you have multiple screens, and there's so many sources.
Yeah,
I really felt the first day, at least, like my pulse went a lot higher, and I'm more calm.
Yeah, it's an experience, and that's why I do it. Also, of course, because I like to share knowledge. And like you said, it's, for example, you mentioned yourself that you didn't hear about Aqua security. Maybe you thought about container security, but maybe not that extensive with all the major risks that are defined for it. So I think it's good if people are more aware of the container security risks and know a little bit about how they can countermeasure those risks. And I think it's a big. First of all, you need to know what risks there are. To be aware of those risks.
Just this report was really nice. I saw there was some. It checked things like Python and.
Versions. But it's also more a shift left regarding security, where you can early in the development process can give feedback to the developers of what issues there are within your image, and And of course, not every image vulnerability has a fix, but within Aqua, you can also acknowledge risks if there's not a fix for it. So that's also an option within Aqua.
I think a lot of people use things like White Source Bolt to check their dependencies in their code, but I haven't seen too much of products like Aqua that checks the whole environment. So
yeah, it's the whole package. I think. You have a couple of those bigger products, but since a year or two now, I've been working a lot with Aqua, and I really like the tool as itself.
yeah. So again, thank you. It was really nice. I don't see we have any more questions.
Okay.
So I think we're done.
Thanks a lot for having me, and I hope everyone enjoyed the session and learned something from it. Mostly, hopefully, learned more than enjoying it.
Yeah. Thank you again.
Okay.
Bye.
Thanks. Bye, everyone.
Hi everyone, and welcome to Global Azure Norway Day 3. For any newcomers to the stream, my name is Oddbjørn Bakke, and I am part of the .NET user group here in Norway who are organizing this event. And I will be your host for this fourth and last session for today. If you have any questions during the talk, please use the chat to post them, and I will include them after the talk. And here is our speaker for this session, Daniel Fontani. So without further ado, the stream is yours.
Hi everybody. Thank you for having me. I'm Daniele Fontani. I'm here today for talking about DevOps and trend of DevOps. Three picture of myself. Who I am. I'm a tracking lover. I am open source fanatic, and in the spare time, I work as a CTO in Sintra Consulting. That's a digital business company. How to keep in touch with me? Here, there are all the link of my social network or my blog, and if you want, you can join and ask me everything. Even after this presentation, I will try to respond and answer to all other questions. But now we can go ahead to the core of this presentation, looking to the agenda. The first part of this session will be about what is DevOps today. In short word, we will explore what was the journey about DevOps since 2009, when Patrick Debois coined this term, until nowadays, and we try to understand how companies and how organizations are managing DevOps problem in their companies. The second point we will focus today is about the future of DevOps. Because as a consultant, as a professional, we have to stay near to the future. We have to be ready for the changes that we'll have in the near future. And finally, we will try to understand how to survive to this change. So how it's possible to keep updated and what are the trends to follow to being ready when the market will change. Well, go through the first step. What is DevOps today, and how companies are using DevOps for bring benefit from these methodologies in their organization. First point, of course, is something that everybody of us already knows, and that's what is DevOps. DevOps, of course, is the practice all put together, development and operation for keeping a team or a person or something inside the company that is aware of what happened between the end user and the operational system. And putting together development and operation, of course, we get DevOps, that not only a word, but it's a mindset where developer and operation cooperate. And this culture spread a lot in the last year. And in fact, this brings a lot of benefits, and that's why we are here to talk about that. And DevOps bring us to process definition and automation of some processes inside the IT. And it brings to better quality, less misunderstood between the teams, an easy way to communicate, because probably we will use the same languages. And there is no more feud inside the company because all is together. Well, but what is the state of art in most companies? For what we understood, DevOps grew quickly and is widespread inside the companies. But not all the companies has a same way for approaching DevOps. So how they organize the team inside their organization. And the third question, the more important question, is how many companies are using DevOps and how they are using it, because you can use DevOps just for automate a single piece of the pipeline, or you can fully embrace DevOps. There are a lot of steps between 0 to 1000%. And now it's time to give some number to you. what happened on the market? The market is estimated of about $8 billion in 2022. That's a very amount if we think to the number itself. But if we follow the research from Grandview Research, the expected number in 2025 will be 12 billion. So it's a huge step forward. So we have space for growth. And if you see the IDC report in the 2023, the number of organizations releasing code for specific application will be increased from 3% to 30%. That's a big step forward. So will be a 10 factor of company that will be using DevOps for deploying application. And the same number is confirmed by CNCF that tells that since the 2018 to the 2019, we have cut by half the number of deployment that are done manually. So automatic is better than manually because, of course, reduce human error and save time and money for the companies. The last point that's not strictly related with DevOps, but I just spoiled some question that will come out later on this presentation. We are seeing a big increase of the usage of Kubernetes. Since the 2080, it was the 58%, now is about 68% in 2019. That's a big number. And what it means? It means that a lot of companies are embracing this technology probably for helping the integration with the DevOps part, like the cloud. Also, the cloud have a very, very big increasing. And this help and fuel the automatization and the DevOps processes. But making a step back, what is really DevOps? DevOps is Kubernetes, DevOps is the cloud, DevOps is technology. No. DevOps is a philosophy. And what it means? It means it's not a team, it's not a person, it's not a technology, it's not a tool. It's a philosophy. It's a philosophy for removing friction, remove constraint, and make everybody aware of what happened between the source code and the servers. So the next step that every company had at some time to phase off is how to implement DevOps. How it's possible to implement a philosophy? Because you need to deploy an application. You don't need to embrace a philosophy. So how we can deploy an application, how we can start a DevOps practice in a company? Well, the first approach that I see in companies is to create teams made of shared resources. So you had development team, you had operation team, you create a new team that is composed by people that in the, not spare time, but in part-time make something on the DevOps side. So this solution, it's very, very spread and is not so bad because the resources that work on the DevOps side or operation side are always updated because they put hands on development things or operation things. So they are updated. You don't have some silos outside the team that work on the project. But the problem here is that we are speaking about people that are not always available because they are part-time DevOps. So this may be a problem when you have something to do in hurry, or when there are some project manager or something like that don't want to be too much agile and want to have to be sure that somebody will answer if we will pick up the phone and call. So another solution that I see in companies is that we can have a team that is an embedded team for DevOps practice. So we are people that work full-time on DevOps, and this resolves the problem that if you pick up the phone, somebody will answer. But this opens some problems, because if you stay outside the operation team, you probably will lose some hard skill, and in few time you may be not so competent. And what we can do here is to add training session or rotate people between teams to keep everybody updated. And this can be done, but is not automatic and may be costly. But of course, you don't have more any double hats or conflict between teams. And the final approach that I have seen implemented in big companies that often work with that are multi-product company, where you have a department that work on the A product and a department that work on the B product. So different department mean different teams, and you can have a DevOps team inside each one of these departments. So you have separated DevOps teams. DevOps teams work near the development team and the operation team, so they are very agile. They are dedicated to the project, so it is efficient, but can be put in place only if you have a very big project to work on. And of course, the other problem is that you work in that way, each team is a silos. Each team is isolated and maybe a different realm. So it's hard to share best practice, to share common rule, and maybe you can have some people that will be not replaceable because of that situation. So, of course, there is no a fitting rule that works on all contexts, of course, but these three scenarios cover most of the situation that you can face on your companies. The last slide about the first part of this presentation is about some number. These numbers are taken from statista.com and report some good KPI for what is DevOps. I will read the most important. If you see the last one, the 6% of the companies never heard about DevOps before, and this are very bad things, I feel. And if you see, only the 10% of the companies fully embraced DevOps. What we are talking about, 10%. The 15% of the companies are considering DevOps but have not yet started. Okay, these numbers are from 2019. So I hope in 2 years things have changed. Of course, it may vary by country. It can vary by industry to industry. Maybe if you are talking to finance, is different than fintech or manufacturing, probably. But the fact is that we have a lot of space. And as a professional and consultant, when we come to a company, when we speak with our boss and so on, we have, of course, to work on the cultural side of the DevOps, because we have to spread the philosophy between starting talking about teams, organization, and technology. We have to spread the philosophy and then get back time and budget for solving this situation that is very hard. But if we want to do that, we have to be updated. We have to be a step forward from what is the need of the companies today. And this is the topic of this presentation, to anticipate as much as possible the new trends that will be in place in the next year, that now maybe are now maybe not all the company are ready for that, but probably will need that in the next year. And just jump to the next section of this presentation, that is the more interesting part. What is the future of DevOps? Okay, we talked about what was DevOps until now, but what are the trends and what are the things that we need to follow for being prepared to the future? First one. This is a buzzword, okay? DevSecOps. This is a buzzword, but it's an important buzzword. It is an important buzzword because, of course, security has been always important, always, since the Stone Age. But with the growing usage of digital services and the storage of sensitive data, I think, biometrical data, photo or just name or credit card number, now it's crucial. Every application hold sensitive information. And the user started asking where their data are and how you are managing. So you have a responsibility on that. And our customer expect that we keep their information secure. We cannot fail on that. There is no B plan. You have to do it right since the beginning. And by the way, the same user that asks for secure data and so on is always more demanding and need to be supported by agile processes for keep the application updated to their need, because we have multiple releases. Sometimes we have to make many releases each day. That's probably the story from Patrick Desbois, and that generated the DevOps terms. So how we can handle these two different needs, to be quick and to be safe? Okay, it's hard, but we cannot have the situation where we finish a project and we will have a bug in production, a security bug in production. We cannot go live without a security check. We cannot do that. But what is the workflow for getting this result? Okay, sorry, too quick. Okay, what is the workflow? Okay, I design the application, I develop the application, or a task, of course. I test it, functional test, I mean. Then, if it is not working, I fix that and go on until the product works as I expect. Well, now it's time for security check. But what happens if security check tell that the application is not safe? You start from the beginning. You throw away days of work. You postpone the go live of the application. All that scenario in modern application are not more suitable. We cannot allow that because it's a wasting of time, a wasting of money. Our competitors will be on the market with the same feature before us, and we will be fired. Not be planned for that. So it is the approach that we cannot more implement in our project management, because we cannot design and have multiple do steps and then check for security only at the end of this process. This is very hard. This is very hard to implement. So the solution, as we have done for dev and operation, you remember, you had dev and operation that worked in different silos, and we understood what was the problem on production only after we put the application on production. With security is something that's it's very similar, not the same, but very similar. So what is the solution? No, you do not need to have too much fantasy for getting something like that. Just put together dev, operation, and security since the beginning of the project. You cannot introduce later the security security problem. Okay, and that's all. That's simple. That's simple to talk. That's simple to explain in word, but in practice, it's not so easy. But it's still not a problem of technology. We have to apply the same technology, the same procedure we do at the end of the project, at the end of the feature. But we have to anticipate since the first test. We have to involve people since the beginning of the project. Well, go through the second point. This is still a buzzword. And the question is self-explicative. NoOps is madness. Depends of the meaning that you are going to attribute to the no operation word. Of course, the negation at the beginning of the word is always like a trouble, but just try to understand better what is the real meaning for me about the NoOps. Of course, NoOps, what is? NoOps means no operation. So the philosophy is to remove all the platform management and the operational part, everything that is between development and production environment. Okay, so we want to reduce the infrastructure impact, the DevOps impact at all. So the purpose of NoOps is to define a process where there is no need to combine the part of development and operation, make things work. Okay, the goal is easy, make things deployable by design with no effort from anybody. Okay, this is simple, not possible. But what we can try to give a further definition to NoOps. The further definition that we can do, because we cannot do that. We cannot remove DevOps. We cannot develop everything. We cannot just put Git source code to the production without any step before. What we can do is something more useful. Is to reduce. Is try to automate everything. Is to reduce the human effort. Is try to reduce the friction, the conflict between teams. So, if you think to NoOps like this concept, so reduce the frictions and automate all you can, well, NoOps is possible, and NoOps is the solution for many of problems you have usually on DevOps scenarios. And of course, this may seem cool, but you cannot forget about monitoring, security, and FinOps, because at the end of the month, you will have a cloud invoice and you will have to pay it. So you have to keep, you have to be aware about the cost and what you are activate or not on the cloud. And you have to monitor and be safe on application. We talked a few minutes ago about DevSecOps, so it's time to put it in practice. Well, another point is infrastructure as a code. Okay, I love code. And why I love code? And why source code is so cool? I love the source code because it is versionable, can be copied and pasted, just for tell one thing, and can be sent via mail. You can execute twice, and if you execute the source code twice, it gives you the same result twice, hopefully. And historically, if I think to sysadmin, servers, virtual machine, data center, is not really the same. You cannot take a data center and zip and send via mail to your colleague, okay? But we would that also our data center, our application, our infrastructure was like a code, okay? Why? Because I could version my infrastructure. I could share with my colleague if they start a new project like mine, and I can replicate it. If I work on B2B fields and I have many customers with the same B2B solution, and I have replicable solution that I can just branch on Git or something like that and deploy, will save a lot of time. And then telling to my sysadmin guys that we need a new server, he have to install Apache or IIS or MySQL or SQL Server or so on. Or if you are in the cloud, just activate a list of services. This is very messy. This is very messy. We want to have an infrastructure as a code that can be run. And if we run the infrastructure twice, we'll create two infrastructure that will be the same. I don't want to talk about disaster recovery and so on, because today I want to be positive, but of course we know that disaster will happen. It's not a matter if will happen or not, but it's just a question of time. So you have to keep also this this aspect of you have to keep in mind this before adopting an infrastructure as a code. This will be very helpful also in this case. So, but how can I implement that? How can I do that possible? Of course, there are thousands of ways to do that. I report here just the three main, the two systems. The Ansible is good for when you work on premise or virtual machine. It's very good. You can automate a lot of things, and it is a good automation tool. Of course, if you are going to the cloud, if you are used to use cloud services or container or Kubernetes, probably Terraform is can give you some extra boost on this. Then the third part that is not a tool for automating such kind of things is Kubernetes. Because, of course, Kubernetes is not something that is used for implementing infrastructure as a code. But the infrastructure that you can create with Kubernetes is described by YAML file. Okay, YAML file are not source code, but configuration file. But if you think to YAML file is not so different from source code. So you can automate the creation of infrastructure starting from the YAML file. And this make not really an infrastructure as a code, but a good starting point if you are approaching to this result, of course. Then you can easily pass to Terraform or other tool that can automate the creation part. Just mention Helm or other things like that. Well, another point, I think the last important point on this presentation is about assembly line. What is the matter with pipeline? Pipeline is how we are used to approach DevOps. So we have stages: build, test, and package, and then deploy to the server. And this scenario was very good when we was working on a monolithic web application. It's probably the scenario that Patrick Debois in 2009 faced when he started to talking about DevOps, because it's easy. You have a monolithic application. You have a repository. You just have to compile and put to the server. Everything is work. But now the situation is a little bit different. Okay, we passed from this simple scenario, so one code base and one linear pipeline, to something more like this, if you are lucky. So you have, if you are lucky, one UI application, Angular application, React application, a single page application somewhere. Then you have a backend, and backend for front-end application that expose API to the front end, so another application. And then the triple dot, all the other systems. So you can have other backend, other system that you cannot control. So this means that you have a lot of actor, lot of cycle of life in the software life cycle. So you may have this. You may have to go live with a fix from the UI, then you can go live with the API, and each changes of the application need changes on the other kind of application. So it's very hard. And we have also the problem of security. we have also the problem of transparency with the management team. So what is the evolution, a possible evolution of pipeline? We have to come back. We have to come back to the beginning of the last century when we started the Industrial Revolution. Okay, this photo is from the Ford Motor Company. As we see, we have an assembly line where all the actors contribute for building a car. That's what we want to create on our DevOps process. So we want that developer, operation, security, and more, testing team, and more, project management, everything give its contribution to the process in this big tool, okay, that will be called island of automation. And all that contribution will be visible to other, will be easy to be aware of what happened behind the hood on your application, on your project. So doing like that, we do not have more a linear pipeline. We have something like more hard. In this simple diagram, we see how the SecOps teams can build new container images and test it. These container images can be delivered by the operation team and included in the process, so that development team just push the source code. Then the testing team see what happened when the new version is ready. Okay, and what I'm telling is not a matter of tool, because we already have tools, but it's a matter of cultural. Even in this case, if we put all the people together in the same process and be everything aware of what happened, it will be easy to dominate the process. And how this island of automation is composed is a tool, a super tool, okay, that has source control, the continuous integration, continuous deployment part, can host artifacts, okay, NuGet packages, jar packages, packages, and every kind of output you can have in your company. We have some testing tool, we have an infrastructure provisioning tool, and we have good system of communication, maybe better a project communication tool, and then finally some deployment target where you can to deploy things. Okay, if you think to your tool, you probably already knows about Azure DevOps. Azure DevOps is a tool that do that. Its cloud has more or less every single feature we need for doing that. If you don't want to do that, you can take multiple tools and put together. Okay, it's not a matter of tool, but this is your goal. Your goal is to bring all the actors, put inside only one process, make that this process is only one and available to everybody. Well, going on to the last point, cloud. Cloud is our friend. We are here talking about on the global Azure initiative, that is, of course, mostly a cloud initiative. We are talking on the cloud and so on. So if we are to start a new project or do something, probably the cloud is the best solution, of course. Sometimes not, because we may have some strict requirement and so on, but this is still not a problem. We can implement a multi-cloud and hybrid cloud solution that can give the benefits from the cloud and satisfy all requirement on the project. So wrapping up my second part of this presentation, what we have to remember about the DevOps trend is that we have to keep security and bring inside the process, inside the DevOps process, for creating safe application. We have to reduce as much as possible the human effort and the friction on the DevOps process with NoOps, sorry. And we have to keep the infrastructure as a code for being replicable and avoid bad situation like disaster recovery without any recovery plan. We are going to create some more complex pipeline than linear pipeline, and we have to start thinking to be cloud native for our next project. Finally, why the future is not so near? Of course, just look back to the number I presented at the beginning of this presentation. Their number is very embarrassing. So we have a lot of space for improving since the cultural layer of the company. So we have to do our best for change the culture in company. And now we have some information about the trend that we will be needed in the next year, so we can bring practical solution to the company. Of course, it's not the same on all the company, all the fields. Maybe what is a standard for me is not for you. Maybe if you work on a tech company, you go fast. And of course, the fact is that some company don't know anything about DevOps. 6% is a very big number. Well, why I talked about Kubernetes on the previous slide? That's about it's a practical solution that can help customers that are reluctant for the cloud and for DevOps to be bring on this side of the progress, because Kubernetes can be run on cloud on premise, is described by source code, so it's quite infrastructure as a code is easy to be automated and can be set up quite easily for who has a background on as a sysadmin, and it is multi-cloud, so the vendor lock-in don't scare too much, and it's a good solution. But we have also a lot of cloud solution like Azure Container Instance that can do the same. So having some infrastructure that is described by source file, that easy to deploy, then reduce the friction and so on. So it's not a technological problem, it's a cultural problem. I hope that in using this presentation, you will get some more info about these practices, and this may be useful for help all the tech community to change this number and spread the DevOps culture on the company, and make that this practice will save money, save time, and help developer and operation to work less and bring better result for quality product and software. So thank you for listening to me. Thank you for having me on this stage. Here again, my social link. If you want to make me any question, even after this presentation, you can do it on all of this channel. I will try to answer to everybody. And then I finished.
Yes, thank you for that. That was a really interesting talk. We haven't got any questions from the audience, but you have some from NNUG here. So you talked about no ops. It seems a very radical strategy. Is it really possible? And what kind of technology do we need to do that?
This is a very huge question. Of course, yes, I agree. No ops is very radical. Of course, something telling to remove everything is creating a problem on development side. But the solution is to think about no ops like a vision to reduce as much as possible the frictions and trying to automate. Automate means to employ technology that require less human effort. So if you use human-intensive technologies like virtual machine, of course, it's hard. But if we start to think to the cloud or to think to cloud solution, well, so we will reduce the need of operation. We will keep things easy, and we can do something that is very similar to the NOPS in the meaning that is possible to implement, and will save time and money because it's quite the same. Time and money for me is the same. So yes, it's possible. I can tell it's possible using the cloud, using the right technology is possible.
Yes, thank you. We got also 2 other questions from NNUG, but they was cut a little bit off, so I can't put the whole question on screen, but I will read it out. So you also talked about a cultural shift for implementing a company-wide DevOps strategy. But why should I abandon traditional pipelines, and how can I expect that the CEOs or manager will be interested in how we deliver software?
Sure, that's another very huge question. Why a CEO should be interested on how we deliver software? Sure, it's quite the same. Why I should be interested in how the engine or my car is working? Of course, I don't want to understand how many pistons of cable are inside the hood. I just want to take the wheel and drive. But the reality is a little bit different because all these cable, all these pistons, all these things on my car can make the difference when I drive the car. And the way where I deliver software in a company may be the difference to the product I deliver. So maybe may make the difference between a business that works or not. So even CEO and management have to start thinking about software development as a part of the business. It's not more a commodity. It's not more optional. So if we work on the cultural way, on the cultural part, and we try to explain that to the manager, we will allocate budget probably for making experimentation and for investing on DevOps strategy. The big problem is that we face the problem, like a technical problem will be always hard to find budget, to be listened by the management, and to find a way for implementing stuff that the company will need. So it's hard. It's hard to make this cultural shift, but it won't be any digital transformation. It won't be any cloud transformation without having a right cultural shift before.
Yeah, thank you. And there was another question here from NNUG. So you talked about infrastructure as a code. Do you think all the companies are ready for that? The cost of the implementation is worth it. What kind of technical solution can help to implement such scenarios?
That's another very, very question that's hard to reply. If I see the number I presented where the 6% of the companies don't know anything about DevOps and are not interested in learning anything, talking about infrastructure as a code is very out of scope for that scenario. But I have to be positive. I have to think that we as professionals, we should try to make this cultural shift possible, explain to that company what we are talking about, and yes, it's possible because technology enable us to do that. So if technology enable us to do that, it's no more a question if it is feasible or not. It's not like trying to going on Mars. We know that there are no technology to send a rocket to Mars. Elon Musk are not convinced about that, but probably it's not possible to send a rocket to Mars right now. We are not talking about sending rocket to Mars. We are talking about deployment infrastructure as a code. We are technology, so we don't have to be scared about that. Elon Musk is not scared about sending rocket to Mars, so we cannot be scared about trying to deploy an infrastructure as a code. It is possible, of course. It costs. It is an investment because deploy nonce cost a little bit less because you just have to taking care about deployment, manage an infrastructure as a code, and additional code, probably the 50% more. So you have to think how many times you will have a disaster recovery plan to be put in practice. You have to think what you are doing. Probably if you are working on a B2B solution is useful, in each case, because you try to sell the same solution with some customization to many customers. So you can just replicate it with just a click, and this will save a lot of time. In other scenario, you do that just for be sure to have a backup and can replicate if you will need. So very depends on the budget and the approach you have to the source code.
Yeah, thank you. I will revisit that graph, the numbers. That was really interesting.
Thank you.
I don't see we have any other questions. So I think that's it. So again, thank you. It was really interesting.
Thank you. Thank you for having me. It was a pleasure.
Good. Yes. So bye.
Bye-bye.
Yes.